Let's find out just how much the James Webb Space Telescope can actually see out there. The actual reality. So hop on board our imagined super-fast spaceship and let's not waste any more time. Now we head to the edge of our solar system, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We've covered 100 astronomical units, and here we are at the heliosphere boundary. Beyond this point, we enter interstellar space, where Voyager 1 and 2 have ventured. Now we approach the Oort cloud, a wall of asteroids 200,000 astronomical units away from Earth. It's sparse, and we easily navigate through the asteroids, entering complete darkness, zooming past stars and planets. We reach the edge of our galaxy within minutes. No more interstellar wind, just bright dots, other galaxies. Mapping our route, we realize our universe isn't infinite. It has a boundary 10 billion light-years away, and there might be other universes. The original supervoid, 1 billion light-years wide, could be evidence of a collision with another universe. But how do we get to these other universes? Black holes might be the key. They're mysterious, warping both space and time. Some scientists even propose the existence of white holes, the opposite of black holes. The idea is that these might lead to other universes. Remember the little bang in 2006? That unusual burst of energy could have been a baby white hole, destroyed almost immediately. Now imagine black holes acting like magnets, drawing matter together with their gravity. But wait, they occasionally fling stuff far away with what they call cosmic winds. Black holes played a crucial role in forming this cosmic web. The researchers think that gravity is the glue that keeps these strands of stars and dust connected, even as the cosmic winds try to pull them across the vastness of the universe. So what's the future of this ancient filament? Imagine a place where the stars stop twinkling and galaxies decide to call it quits. What secrets could be lurking beyond this newfound boundary? Are we on the brink of unraveling the greatest cosmic mystery? Or is this just the beginning of a whole new chapter in our cosmic adventure? Well, it seems it is. Webb claims to have found the end of space itself. Yes, you heard it right, the final frontier might not be so infinite after all. But hold on a second, how can space have an end? Wasn't it supposed to go on forever? Let's see what's really happening. When I heard this news for the first time, I was all pumped up to uncover one of the many mysteries of the universe. The James Webb Telescope has been doing just that, and it's flipping our understanding of the cosmos on its head. In just 12 hours of observation, this marvel showed us things that left us staring wide-eyed and scratching our heads. Let's imagine together how vast the universe actually is. Just let your imagination run wild and think as far as your mind can go, reaching the very edge of space. Now let's talk about the Andromeda Galaxy heading our way at 68 miles per second. Don't panic, it won't crash tomorrow. But when it does, things get interesting. We might witness stellar collisions, or perhaps our solar system gets thrown into dark space like a tennis ball released on a rope. Fast forward, the galaxy merge and the black holes at their centers start a dance. They eventually merge into a supermassive black hole, releasing energy and an active galactic nucleus visible for millions of light years. Then we've got the South Pole Wall, 500 million light years away, containing a quadrillion stars. There's also the Hercules Corona Borealis Great Wall, a flat superstructure 10 billion light-years wide. And don't forget the huge Large Quasar Group, 4 billion light-years across and 6.1 billion times heavier than our Sun. And then there's the observable universe, over 500 billion galaxies, each with billions of stars. But wait, there's a void called the Aridness Supervoid, or the Cold Spot, 1 billion light-years wide. Some think it's a result of a collision of universes, two bubbles touching and tearing material away. Now picture the universe as a giant bubble, and there might be infinite bubbles, Wormholes or portals inside black holes could be shortcuts between these universes. Imagine folding a piece of paper to connect 2 points without crossing the whole sheet. That's the idea. Speaking of black holes, falling into one could be survivable if it's supermassive. Gravity's effect increases gradually, avoiding the dreaded spaghettification. Who knows? Surviving a fall might land you in a different universe with different physics, though for now, it's just a wild theory. So imagine you're out on a clear night gazing up at the stars. It might seem like they're spread out evenly, right? Well, it turns out that's not the case at all. Those stars are actually part of something massive, a gigantic cosmic web connecting galaxies across the universe. Astronomers using the James Webb Space Telescope have just stumbled upon what could be the oldest strand of this cosmic web ever discovered. Now let me break it down for you. In 2 papers published in the Astrophysical Journal Letters, scientists spill the beans on this incredible find. They use data from the James Webb Space Telescope to uncover a colossal tendril made up of 10 closely packed galaxies. It stretches over a mind-boggling 3 million light-years. Xiao Fan, an astronomer from the University of Arizona and part of the research team, couldn't contain his surprise, saying, "I was surprised by how long and how narrow this filament is. I expected to find something, but I didn't expect such a long, distinctly thin structure. It's like stumbling upon a hidden ancient treasure in the cosmic vault." This ancient filament of gas and stars dates back to a mere 830 million years after the Big Bang. That's practically the universe's baby years. And guess what's anchoring this colossal thread? A supermassive black hole, of course. This black hole is no ordinary one. It's a quasar, an extremely bright celestial object that acts like the anchor for this cosmic structure. The team behind this mind-blowing discovery is part of the ASPIRE project. What's ASPIRE? Well, it stands for a spectroscopic survey of biased halos in the reionization era. Fancy name, right? Their mission? To figure out how the earliest black holes influenced the evolution of galaxies. And guess what led them to this ancient filament? One of the 25 early universe quasar they had their eyes on. Fei Zhuang, an astrophysicist from the University of Arizona and the brain behind ASPIRE, is pretty excited. This is one of the earliest filamentary structures that people have ever found associated with a distant quasar, he exclaimed. It's like they stumbled upon a cosmic treasure map revealing secrets of the universe's early days. Well, the researchers believe that over time, this cosmic thread will condense into a cluster of galaxies, kind of like the Coma cluster, which is about 330 million light-years away from us. It's like watching the universe evolve and create its own intricate masterpiece over millions of years. When the Webb telescope focused its mirrors on a patch of sky, it saw way more light and way more galaxies than expected. Not just any galaxies, but big bright ones. Now scientists are scratching their heads and coming up with different possibilities to explain this cosmic mystery. And let me tell you, these possibilities are like forks in the road, each leading to new questions and understandings. We can bring those details for you in the next part, so make sure that you hit the subscribe button and press the bell icon for regular updates of our channel. See you in the next interesting video. Until then, thank you for watching.